Great, thanks for joining us today, and I'm glad to be up here. So, Cloud Services Architect, that means that the stuff that I'm talking about today is schemes and dreams, and luckily I've got my team here with us today and kind of spread around the audience to actually hopefully implement the stuff that I'm talking about. So if you have any hard questions about what we're doing, ask my team rather than me. So let me go ahead and talk through. So Cloud Services, CCATG, we're a little bit like a government organization where we have very long acronyms for our names. CCATG stands for Collaboration Cloud Application Technology Group. There's a number of services within Cisco that we deliver as SaaS to the market. We actually are one of the largest SaaS providers of business services, business SaaS services in the market. So you don't usually think of Cisco as a SaaS company, but in fact, with Cisco Social, which you might have heard Keith Chambers and Ryan Uber talking about yesterday, Connect, which was the messaging application, and WebEx, which of course our hosted teleconferencing service. We have a very large footprint of SaaS applications. And so our job, my team's job, is actually helping deliver these applications. And so clearly, running these things from multiple environments is a big task. We actually have, on a monthly basis, we host millions of meetings for tens of millions of individuals. If you add up the minutes in those meetings, billions of minutes of meetings on a monthly basis. The interesting thing from an operations viewpoint about this, we don't ever get to turn it off. There's no scheduled downtime for a WebEx meeting. It's run effectively like a web business, where there's no IT scheduled downtime. There's no moment where you can't go launch a meeting. And so that kind of drives a lot of what we think and what we do in terms of how we deliver our services. And so we actually have a global footprint. The number of data centers varies depending on migrations and when we're going from place to place, but as we're optimizing for the environment. We've got a fairly small number of hosts, certainly by a Google standard, for example, or an AOL or a Yahoo standard. But we do spread across the world. And because of the way we deliver our services, the fact that they're audio-video streaming services, we do have to have a larger footprint. So we run 8 data centers, roughly, in data center pairs across the world. And then we have what we call IPOPs, or points of presence, that are distributed around for delivering edge locations, anywhere that you have to connect to a large number of providers to reach out. And so places like Miami and Chicago and Reston to connect to the world. So, and then we have a private backbone connect everything. So enough about that. Ultimately, what's deployment automation? What are we doing, and how are we delivering services? At the end of the day, it's about keeping those screens green. We all, everybody's seen a NOC. You've got the big screens kind of with the health of the systems. Our goal is to actually keep all those screens green, keep all the meetings flowing, everything running while we evolve the system. We can't ever turn off, so we have to be able to say, how do I manage these systems over time without ever turning the services off? So as we look at systems, and everybody who works with me ever knows that I spent some time as a cabinet maker and remodeling contractor. And the interesting thing is, if you look at a system and you look at whether it's our data center stuff or whether it's a set of cabinets, it's easy to be overwhelmed by the scale of kind of this system. What are all these? How do you get to that? How do you actually create that thing? Well, the reality is that a system like that is quite simple. There's a bunch of cabinet boxes, carcasses. We assemble our carcasses into modules, cabinet modules, and we put them together in a particular way. We stamp out multiple copies of the things. And we ultimately advance the slide. Twice. So we actually, ultimately, we finally assemble these things into a system, into a running system. Well, that all has to happen in a prescribed order, in a prescribed way. And so sorry to pause. Let me try this again. There we go. So in our systems world, of course, we have the same kind of thing. We have these fundamental little atoms of our systems. And in Puppet, we call these resources, right? Our systems are composed of simple resources that are composed together in a particular way. And so in where I'm dealing with carcasses in the cabinet world, I'm dealing with packages, files, users, kind of atomic elements that I construct these systems up from in the Puppet world. And then we compose those up into more higher order systems. And all of this is stuff that we're dealing with on a day-to-day basis. In many of the sessions, we're talking about modules. How do you build a module? How do you manage resource X? How do you do all these things? But there's actually a big piece of what we consider kind of the thing that dominates my mind as an operations guy day in, day out, is missing from kind of this description of a system as modules or these component parts. And that thing is time. The thing that dominates my day in, day out, is actually time. So a couple aspects of time. The first is, how do I get specific versions to evolve on the system over time? I have a particular module, a particular system that's running v1. It needs to get to v2, or Elasticsearch v.2 to 0.9, whatever it happens to be in your environment. So ultimately, the first thing is, how do I evolve versions over time on these systems? And so in some systems, you get to just whack the system overhead and create a new system and tip it up in the face. So the front-end nodes in a network, for example, are very typical this way. But other systems, we actually, in particular our database servers, we have large data sets on those systems. I can't just whack it in the head and replace it. I have to evolve the versions that are on that system as we go forward. And so how do we do this? How do we kind of manage these systems over time? And the others, we rarely ever, even if we have an entire front-end set of servers that are switching to another set of servers. Gordon talked about this yesterday in the Google presentation, for example, is that you rarely do a big bang, right? You do a canary cluster, or you do a set of systems. How do you manage those releases through those systems, again, through time? The second big chunk of this, and kind of related to that last point, is that every release of every type that goes into our system has to be done in a particular system sequence. So this slide you'll actually see. We see shared services, WebEx 1.1, Connect centers. This was a particularly horrific upgrade where we had a lot of dependencies between these services, where we're changing out a set of common services. And so we not only had to go through a single service in a prescribed sequence, but also across multiple product lines where they actually are interrelated with each other. Each of those red circles represents, in addition to the time we have to think about as a operations team, how do I do a particular upgrade, we also had customer communications requirements in there. A company like a large retail organization is really unhappy if you do an upgrade on Black Friday. It's like you just can't do that. It's just completely off the table. And so the sequences, both in terms of technical sequence, how I get through a process, as well as business sequences, how do I get through the process, kind of dominates our world. So we've done a number of different tactics to start to kind of deal with these things in our world. And so that's what I'm going to talk the remainder of this about, is how we kind of think about time rather than just specific configurations of a specific machine. And so first thing is, we never ever run just one of anything. Gordon mentioned this one yesterday as well, is that we don't have one data center, we have pairs. We don't have one node, we always have clusters of nodes. And the versions that, what is running in a cluster is wildly dependent on the actual service that cluster is running. So some of the things that tell us what things we put in what cluster there can be technical reasons why we cluster things. Things like Cassandra clusters are the obvious example where it's designed to work in a cluster. Then we have business drivers that put things in a particular cluster. A commercial retail cluster versus a federal cluster versus other kind of business drivers or data privacy requirements that make us do these things. So when we're managing the clusters and moving the clusters over time, we have a number of different strategies and different ways that we run versions of software and migrate from one version to the other across those clusters. So getting from version 1, sometimes we will do it by data center, so do an upgrade from one data center to flip all traffic out of a data center, upgrade one side, flip all traffic back to the other data center. Sometimes that works. Other times we'll actually running a common version across multiple data centers, then we bring in nodes that are running the new versions into those data centers. And one of the, as we go through over time, these things are planned on a per application, per cluster basis, depending on the needs of that particular application, and they're not all the same. So the cluster management and understanding this time and sequencing requires a different set of tools often than what we're actually using to manage the individual configuration of individual machines. So just as a cabinet maker we'll have a set of plans or a set of specifications for how do I build this carcass or this cabinet, that cabinet lives in a larger structure, right? It gets installed in a kitchen or in a bathroom, and that has to be done in coordination with all the other trades that are working in the house. And so the first thing is, how does this piece, this component that I'm specifying using configuration management, fit in the larger infrastructure? And so we use modeling tools. We very often will use there's a lot of experimentation that we're doing in this area, but for many clusters, we have a JSON description of saying this is what the cluster looks like. It has 12 nodes. Each node is running this version, has these characteristics. There are actually some open standards developing around this area. Tosca, if you Google Tosca, you'll find some interesting work around that. CloudFormation, if you're in the Amazon ecosystem. Heat, if you're in the OpenStack ecosystem, are kind of addressing this kind of cluster definition thing that we're doing. So the second big part of that, if I've got a model that describes what my environment looks like, how do I go from that model to the running system? How do I move from place to place? And so we end up using things that manage sequences and interpreting that model and applying them. And so that's where kind of orchestration comes into the picture. If I take a model describing what I want, I've got Puppet configuration that describes what I want to get to for an individual machine, and then I glue it together using orchestration tools. And so there's a little analogy I like to use in some of these things. The GitHub folks yesterday were talking about the Unix tool chain and applying the Unix tool chain to our configuration management and orchestration needs. And it's something that we live by a lot. You know, it's very, again, back to the construction analogies, you'll find very few contractors who don't wear one of these on their belt. And a standard multi-tool Leatherman. And if you need a quick knife, you need to solve a little problem, this tool sitting in your pocket goes a long way to solving specific things. And so it's very tempting to say, okay, that's my tool for everything. And so as we look at building configuration management or orchestration systems, it's very tempting to say, hey, let's find the one tool that does everything for us, because it's simple. It's always right there. We have it handy. It's well integrated. It's always available. But sometimes when you need a knife, that just doesn't cut it, right? I mean, sometimes you have a real job that needs a real tool. And so most contractors will have something like that sitting in their toolbox. So when they need a knife, they've got a knife. And so we approach our version control and management the same way. It's like sometimes a little integrated tool that does a lot of things. Fabric, Salt, Ansible, all of these products actually have a little bit of configuration management capability in them. But we don't really use it for that. We primarily use that for orchestration, for making things happen in the right sequence, interpreting these models. But when I really need real configuration management, something that will allow me to very accurately, precisely, in a controlled, software-defined kind of way, my configuration on a system, that's where I turn to Puppet. That's my configuration management in that world. So anyway, so that's a digression. So we really think about, how do I use these tools and chain these tools together to build these systems. So I'm going to digress a little bit here, and one of the big conversations that happens a lot in our organization is and you've heard a number of different discussions about, how do you manage that Puppet master? How many Puppet masters, how do you actually manage a single thing that's controlling your whole infrastructure? And so the line in the text is a little hard to read there, but data center 1, data center 2, do I build a single Puppet master that kind of spans my environment and I drive my whole environment from that data center? If I do that, what happens when inevitably I lose connectivity between my data centers? The reason I'm building 2 data centers in the first place is for resiliency, right? And so actually having a single Puppet master span those data centers is problematic when there's a problem. Problematic when there's a problem? Whatever. Anyway, and in fact, the time that you most need to make changes in a controlled manner to your infrastructure is when something's breaking, when something is going wrong. So we typically don't have a single Puppet master that's controlling our whole world. The next step that actually is kind of an obvious next choice is building a Puppet master in each data center, in each facility that kind of controls the resources in that facility. Some of our systems, in fact, do this, where we have large classes of systems in a single data center that run off one system. But the challenge with this particular one is this. I'm not sure. This was from a couple years ago, DevOps Borat. This is, if you don't subscribe to DevOps Borat on Twitter, I highly recommend it. It's always good for the morning, spitting your coffee up because you're laughing thing. But yeah, this is one of the challenges of putting all of your eggs in that particular basket and controlling. There's a lot of benefit to having a single point of control for everything in your infrastructure. There's also a tremendous amount of risk to having a single control point for everything in your infrastructure. And so there's actually having lots of distributed puppet masters effectively for individual nodes or individual clusters of systems gives you firewalls, gives you isolation, fault domains between your different environments. And so we use this technique quite a bit. So in fact, Keith was, in his presentation yesterday, talked about in the quad environment, we have a director node in a cluster of Cisco Social. Cisco Social, we used to call it quad, but in the Cisco Social cluster, which delivers that particular service, each cluster has its own director node, which is a puppet master for that node. And so that's a pattern that gets followed sometimes. And so depending on whether it's a product boundary or a particular federal cluster that our non-US operations personnel can't log into, for example, or various other reasons like that, we tend to split these things up. As soon as I start doing that, I start saying, well, there's actually another what's interesting is I have to distribute Puppet modules to all of these things. I have to actually manage the distribution of the software to my Puppet masters, and how do I manage that, and how do I do that kind of thing? And so that actually leads to an interesting case where, and in fact, something we use in development all the time when we're applying Puppet to our local Vagrant boxes to test a Puppet module. Why don't I forego the Puppet master entirely? What if I just distribute the Puppet modules directly onto the machine that they need to run and apply the nodes from there? And so this is something that's gaining a fair amount of steam around both in our environment and to some degree in the community as well. If you Google masterless Puppet, you'll find a few interesting postings on that. So actually doing this, how do you get those? How you get the modules onto those boxes is an interesting question. And so being able to do a copy these things onto the nodes, managing the software on the nodes. Okay, now wait a minute, I'm duplicating the effort that my Puppet master would have done for me. But I get some interesting advantages. I get complete resiliency on a per node basis. I get the ability to, I don't have that single point of control that I have to manage very, very carefully. I can have systems that disconnect and reconnect. There are lots of interesting things. We know, in fact, how to run these modules once they're on the box. We do it in dev all the time. And so doing a Puppet apply with the execute the particular server type, Puppet handles this very, very easily. So as it turns out, we know how to package things and get them onto our computers, right? We know how to use the package bundles of software or configuration. We have very robust package management in our OSs today. And so whether you're using RPMs on the Red Hat world or Debians in the Ubuntu Debian world, we know how to do that. We know how to package things. We also know how to run software repos that I can install these things from. In fact, I have to do that in my environment anyway because we're building software that we're distributing. And so that infrastructure and that tooling is already there. And so how do we leverage that? So it makes it very easy to actually distribute Puppet modules to a box and run it. Now the next question is, how do I do that? How do I go out to every box and say yum install foo or upgrade foo? And so that gets us back to using kind of the right tools for the job again. And so I use remote orchestration tools, whether they're Fabric or mCollective, Salt, Ansible, any number of remote execution tools to go out and touch a box and make something happen. So I'm not going to dive into this too much more because Sam is going to actually have a whole nearly hour-long session where he covers a lot of the same topics. It was a fortuitous event, actually, that I sat down with lunch with him yesterday, and it was like, you guys are doing very much the same thing we are. And so I'm glad that I don't have to go into too much more detail here because I assume that you'll be talking more at the afternoon session. So what time is that, Sam? 4:10 here-ish, I think, right? So in this room. So at 4:10 in this room, you can hear more about this. As we compared notes, completely working independently of each other in different corners of the world, in fact. We're like, hey, we're using a very similar methodology here. So I'm looking forward to that session and some more details there. So rather than go into the gutty, gory details of this, I'm gonna kind of strip gears a little bit and talk about some other things. First of all, so I've laid out single Puppet master, multiple Puppet masters per data center, individual machines. Which one do we use at WebEx? All of the above. Depending on the application stack, the age of the application, where the application delivers to, there's never just one way to do it, and Puppet gives us sufficient flexibility that we can actually tune a particular solution to that particular need. And so our application stacks are not all homogeneous. The way that you manage an Oracle cluster is very different than the way that you manage a Cassandra cluster, for example. And so we have different solutions for those two things, even though they're both clusters in our world. Certainly, we share code between those. Our base, well, we'll have to see a picture in a minute. Share. By keeping these things independent, we can manage their life cycle of each cluster independently. We don't have to get into this rat's nest of dependencies and managing the whole thing over time. And it's much, much easier to solve small, narrow point solutions. Like the old saw of how do you eat an elephant one bite at a time? Well, how do you manage a massive cluster of machines? A handful of machines at a time, and then you grow up from there. And so we don't try to solve the big problem. We solve little problems and then build out. So this is if you look up on Wikipedia, this quote, it's actually, you always hear consistency is the hobgoblin of small minds. Actually, it's a foolish consistency is the hobgoblin of good minds. And the point is that there's times when consistency matters, and you want to drive that. Our OS security hardening modules on our base OS has to be consistent across the entire fleet. The way I manage a software restart for a cluster is never going to be consistent. It's never going to be the same for one application stack versus another because they're different applications, most of which we didn't write. We're getting from the open source community. So no matter how you distribute the code, no matter how you run your software in your environment, at the end of the day, Puppet is code, and you have to manage it as code. And you'll hear a lot about this at the rest of the sessions. But ultimately, every artifact is versioned. We package and release those artifacts. It goes through the same build, controlled cycle that all of our other software does in our world. And everything that you think about in writing good software code applies to your Puppet modules. Clean interfaces, code reuse, testing, sharing. I always put sharing as part of the fundamental property of this stuff because it helps with consistency, reducing effort, reducing bus factor so that if one guy gets hit by a bus, you still have other people who can fix the problems. Lots of reasons to do this. So talk a little bit about just kind of the way we manage. I'm going to go a little scattershot here, but a little design pattern we follow. First is the server type profile module. I will credit, let me just skip all through the slides. Modules are atomic, very small, simple, single-purpose modules. We bundle those modules into easily consumable chunks of data. Something describing a base OS, for example, which would include monitoring and the other things. The monitoring modules are individual. The base, like an SSHD module, is independent. We bundle them into digestible chunks so that someone can just say, oh, I need a new server, and they can pick that up rather than having to know really what's in there. And then stack them up into consumable pieces. Every machine is ultimately a particular server type that fully specifies what that machine is. We were highly inspired by Craig Dunn's role profile modules post that he did probably a couple years ago now. Our terminology is a little different to kind of meet our needs and the way our teams have been working over the years. They're all just modules. So one interesting bit is that we do use Puppet, and I believe, Sam, you do the same thing. We use Puppet Librarian to actually, we have the structure effectively is defined in the modules. The specific versions of a specific module that's included in a particular server type is defined by Puppet Librarian and the Puppet file in Puppet Librarian. So anyways, we can talk about that offline. Everybody wants to grab us. So I have 1 minute, 36 seconds remaining, so I'm going to plow through here so we can keep on track. We do another pattern that we follow in designing our Puppet modules and manage our stuff is what we call cooperative modules. I don't expect we're running a closed ecosystem, right? My servers all look roughly the same. My environment, I always do monitor systems in exactly the same way. And so I don't have to expect my Apache modules to install and manage or include monitoring, the full monitoring stack. All we need to know is that we use a particular type of monitoring, and in order to be monitored, my modules, all they need to do is manage their configuration for that. That we can drop an include file that the monitoring system can include, or that whether it's monit or collectd in our world, startup scripts, log rotate scripts. There's a bunch of patterns where we don't try to make the small module understand everything about monitoring. We just have a handshake agreement between modules and how we run these things. And that works in our environment because it's all our environment. We run machines the same way, and so it simplifies our module design quite a lot. There's a bug in that code, by the way, in the theme of having bugs in codes. And so if you guys look at this deck online, you can try to figure out what the bug is. We discovered it a couple of days ago. I'm not going to cover this too much because I already talked about it. The fact that the way we compose modules is through the server type, and the specific versions of things that are included is through that Puppet file. Great product. Project, Puppet Librarian. So my time is up, it says, which is good because I'm on the last slide. The miscellaneous tidbits, one of the things that's interesting in our world is we try to push as much as possible out of RPM dependencies. It's a little different from what Keith is doing, actually, and kind of to highlight that not all teams are the same even within our organization, but we try to push all dependencies into Puppet as opposed to into RPMs because it's, to us it's much more transparent. We call this 4 a.m. proofing something. When I have to sit down on a system and grok what's happening at 4 a.m. when something broke, I want things to be as simple and transparent as possible. So if someone logging into that system, sitting on looking at that Puppet, Etsy Puppet, can know exactly what's supposed to be on the machine and how. And so that's this is transparency and simplicity for us trump the dry principle, for example. It's okay to repeat myself if it makes it easier to debug in the middle of the night. So. Along those ways, we tend to use composition as opposed to inheritance just because it's easier to trace and view. So I'm going to skip right to the end. I'm actually going to skip over this because this is the thing that Sam, I know, has more detail on. I'm not going to go into the details of how we go through these paths. I'm happy to talk to anybody offline on it. But the bottom line is, the same code, the same Puppet stuff is used through the entire dev cycle, from developers' desktops running on Vagrant boxes, through QA, through production, externalizing all data and metrics, and then going backwards and pushing that stuff back. The key is making sure we're all working off the same modules so that we get this virtuous cycle of development. So that's it. So I haven't seen a lot of this here at this conference. At the OpenStack conference, it's a running joke that every deck ends with, "We are hiring." I don't know anybody who's not hiring, so we are hiring. So anyway, I probably have time for 1 or 2 questions, maybe, or one? Nope, no questions. You'll have to find me. You'll have to find me out in the audience, and me or any of my team members, and be happy to answer questions. And I do highly recommend Sam's session this afternoon. I'll be there as well. So.
Thank you, Reinhardt. Cheers. Never cut a man short with a knife.